Okay, in this section, we talk about volume by slicing, general slicing method. Suppose a solid object extends from x is equal to a to x is equal to b, and the cross section of the solid perpendicular to the x-axis has an area given by a function a and is integrable on the interval a to b. The volume of the solid is v is equal to the integral from a to b ax dx. A is what? The area. Okay, so let's solve the first example so you will understand what I mean by this. The first one is the volume of a parabolic cube. Let R be the region in the first quadrant bounded by the coordinate axes and the curve y is equal to 1 minus x squared. A solid has a base R and cross section through the solid perpendicular to the base and parallel to the y-axis r squared. Find the volume of the solid. Okay, so for the first problem, I'm going to show you the graph. So you can see this distance is 1 minus x squared. This is 1 minus x squared. And this is the square base. The square slice. Okay. And this is the base of the solid. You can see the volume that we are looking for is right here. So we will go ahead to just write. You can see okay, so now you can see we'll focus on a cross section through the solid at a point x where 0 is greater than or equal to x and x is 0 is less than or equal to x and x is less than or equal to 1. Why? Because what we have is 1 minus x squared. So that cross section is a square with side of a length. The side of a length is what? 1 minus x squared. Therefore, the area, the area would be 1 minus x squared times 1 minus x squared, because you can see I times the base, which would be, the area would be 1 minus x squared to the square. So in that case, to find the volume will be from 0 to 1, 1 minus x squared dx, which will be the integral from 0 to 1, 1 minus 2x, 1 minus 2x squared plus x to the power of 4, yes, dx. Okay, and by integrating, I know you know how to integrate this one. By integrating this one, we'll get x minus 2/3 x cubed plus 1 over 5 x to the power of 5 from 0 to 1. And if you substitute 1, because if I substitute 0, I will get 0. So if I substitute my 1, I will get v will be 8 divided by 15. That will be my volume. Don't worry, you will not be asked to graph, but you need to know how to find because by looking at this one, the x cannot be negative, so we start from 0 to 1. See, 0 to 1. And same thing, okay? Let's move to the next one. So for this example, the volume of a parabolic hemisphere. So a solid has a base that is bounded by the curves y is equal to x squared and y is equal to 2 minus x squared in the xy plane. Cross section through the solid perpendicular to the base and parallel to the y-axis are semicircular disk. Find the volume of the solid. So let's find the volume of this solid. Let me post the graph. So you can see the cross section perpendicular to the x-axis is a semicircular disk, right? Look, it's a semicircular disk, this one. Then the area of the cross section, this is R. The area of the cross section is 1/2 pi times R squared, where R is the radius of the cross section. So of course, to find R is equal to 1/2 2 minus x squared minus x squared. And by doing this, we can see R would be 1 minus x squared. To find this R, because this is y is equal to x squared, and this is y is equal to 2 minus x squared. So to find the radius is 1/2 a distance, right? Okay, so now, because to find this distance, right, you can set is y2 minus y1. But since the radius is half the distance, so that's why we have half. Okay. So again, don't forget, the key observation is that this radius is 1/2 of the distance between the upper bounding curve, which is y is equal to 2 minus x squared, and the lower bounding curve, which is x squared. So that's why the radius is 1 minus x squared if you solve this one. So this means the area AX will be what? 1/2 pi r squared. So our r is 1 minus x squared to the square. So for now, we need to find the limit of integration. So you can see the intersection. Let me write again. Limit of integration, which is the intersection of the two curves, right? The intersection of the two curves, which is 2 minus x squared, is equal to x squared. Once we solve this one, you can see this is equivalent of saying what? 2 is equal to 2x squared. So the solution would be what? The solution for this equation are x is -1 and x is 1, right? So those are my, and limit of integration. So now I would just set my volume. So we know the volume is V is equal to the integral from -1 to 1 ax dx. So which would be the integral from -1 to 1 pi over 2 1 minus x squared dx. You know, pi over 2 is a constant. So this is the same thing as pi divided by 2. The integral from -1 to 1, 1 minus 2x squared plus x to the power of 4 dx. And I believe you know how to integrate this one, which will be pi over 2 x -2 divided by 3x cubed plus 1 divided by 5x to the power of 5 from -1 to 1. And then by calculating this one, you will see the volume V would be 8 pi divided by 15. I hope you understand. Let's move to the next one. So the disk method about the x-axis. So don't forget we have the disk method about the y-axis as well, okay? Let f be a continuous function if f of x is greater than or equal to 0 on the interval AB, so which means f of x is positive on the interval AB. If the region R bounded by the graph of f, the x-axis, and the line x is equal to a and x is equal to b is revolved about the x-axis, the volume of the resulting solid of the revolution is v is equal to the integral from a to b pi f of x squared dx. Okay, so let's do this example quick. Let R be the region bounded by the curve f of x is equal to x plus 1 squared, the x-axis, and the line x is equal to 0 and x is equal to 2. Find the volume of the solid of the revolution obtained by revolving R about the x-axis. So again, by graphing this f of x, so you don't need to sketch, but this is the explanation, so please bear with me. You know, the graph of f of x is equal to x plus 1 square when from the point 0 to 2. The shape of the graph is parabola, because at 0 that's 1. Will be something like this, right? And we know this point is 1, and let's say this is 2. So this is like my R. This is the x-axis, right? So let's say this is x. So I went back a little bit to better explain this part to you. So you know, this is the sketch of f of x is equal to x plus 1 square. So just when the region, this R, right, is revolve about the x-axis. So revolve means symmetric about the x-axis, okay? The red graph similar to the green one. It generates a solid revolution across, and this is the radius again, r, which is x plus 1 square, right? A cross section perpendicular to the x-axis at the point 0 less than or equal to x, which is less than or equal to 2, because this is 2, set from x is equal to 0 to x is equal to 2, is a circular disk of radius f of x. So the radius is r is same thing as f of x in this case, which is x plus 1 square, right? Therefore, a typical cross section has an area. My area AX would be pi times f of x square, which is what? Pi times x plus 1 square to the square again. So integrating this between 0 to 2 give us the volume. So our volume V would be the integral from 0 to 2 ax dx, which is equal to the integral from 0 to 2 pi times x plus 1 square to the square dx. Don't forget, this is what? The disk radius, right? So by doing this one, of course, pi is a constant, so pi can go out, the integration. So pi, the integral from 0 to 2, and this would be x plus 1 to the power of 4 dx. So you have learned how to do integration. So the best and the faster way to integrate this one is using substitution. So I would just say let u be equal to x plus 1. So don't forget, if you do that, the limit of integration also will be changed, because this limit of integration is the x value. X is 0 and x is 2. So you need to know when x is 0, then u will be what? 1, because you substitute 0 for x. 0 plus 1 is 1. And when x is 2, u will be 3. So this same integration, if I use substitution, it will be pi times the integral from 1 to 3 u to the power of 4 du, because if u is x plus 1, so that means du would be equal to dx, right? So by integrating this one, this will give us what? Pi 1 to the power of 5 u to the power of 5 from 1 to 3. And if you substitute your 3 and your 1, you will see you will end up having a volume which is 242 pi divided by 5. Okay, so I know I went back a little bit to explain this because I want to make sure you really understand. So let's talk about now the volume by the shell method, okay? Let f and g be continuous function with f of x greater than or equal to g of x, which is positive, greater than or equal to 0 on the interval AB. Let R be the region bounded by y is equal to f of x and y is equal to gx, and the line x is equal to a and x is equal to b. When R is revolved about the x-axis, the volume of the resulting solid of revolution is V is equal to the integral from a to b pi times f of x squared minus g of x squared dx. So this is between what? Two function, right? If it's revolved. So let's go ahead and do this example as well. Sorry, this is a washer method, okay? This is washer, I mean to put washer method. Not the shell method, sorry. This is washer method about the x-axis, okay? About the x-axis. So you need to know something about the washer method. In this case, f of x is greater than or equal to gx, right? So f of x is the outer radius, okay? And g of x is the inner radius all the time, okay? So let's do this example. The region R is bounded by the graph of f of x is equal to square root of x and gx is equal to x squared between x is equal to 0 and x is equal to 1. What is the volume of the solid that result when R is revolve about the x-axis? When R is revolve about. So again, you need to have an idea about, in this case, between f of x and gx, which one is the inner and outer radius, okay? And you can only do that by graphing or have an idea about how the graph will be. So you know, if you look, the graph of square root of x is, let me use, the graph of square root of x, which is f of x, would be something like this. Right? Or the graph of g of x, which is square root of x, will be something like this. Don't, again, I'm just sketching so you can see, right? And this will be my R. So when we said revolve across the x-axis, so the same graph that you have here, let me just make this one like a dot. Sorry. I do wanna make sure you see. It's always better to get a graphing calculator and sketch so you will see what this shape will be. So this is N. So this will be the volume we are looking for. And this is the disk. As this is R, you would have your disk like this. Okay? So by looking at the graph, you can see which one is the inner and which one is the outer radius. So you can see the region bounded by the graph of f and g with f of x is what? Greater than g of x. And if you check between 0 and 1, that's right here, because both graphs cross at 1, right? So the Washer method is applicable in this case. And the area of a typical cross section at the point x is ax is equal to pi times f of x square minus g of x square, which will just give us pi. What is our outer function? That is the red one, which is square root of x, right? This is f of x is equal to square root of x, and this is g of x is equal to x squared. So pi times, let me use the brackets, x square, because f of x squared minus g of x is square root of x. Oh, sorry, I mess up. This is square root of x because that's my f of x. That's the outer function. Minus g of x, which is x squared square. So if you check, square root and square will cancel out. So this one will give us what? X minus x to the power of 4. So our ax will be equal to pi times x minus x to the power of 4. So which means now our volume that we are looking for, V, will be 0 to 1 pi x minus x to the power of 4 dx. And by integrating this one, we will get 1/2 x squared minus 1/5 x to the power of 5, the integral from 0 to 1. You know, if I substitute 1, I'll get 1/2 minus 1 over 5. And if you substitute 0, you will get 0. And don't forget the pi. So the volume would be 3 pi divided by 10. 3 pi divided by 10. So again, so this is the disk and washer method about the y-axis. So we are about to do the same thing again, but it will be what? Revolve above the y-axis. So which means we will be, if the function is given in terms of x, we have to find the inverse function. We have to rewrite it in terms of y. Okay, let p and q be continuous function with py greater than or equal to qy, which is greater than or equal to 0 on the interval CD. Let R be the region bounded by x is equal to py, x is equal to gy, and the line y is equal to c and y is equal to d. When R is revolved about the y-axis, the volume of the resulting solid revolution is given by V is equal to the integral from c to d pi py square minus qy square dy. If qy is equal to 0, the disk method result V is equal to c to the integral from c to d pi py square dy. So you need to know the difference between the disk method and the washer method is just if qy is equal to 0, you need to use the disk. If preferable is used to use the disk method. But if qy is not 0, then you have to use the washer method. Okay? Any question? So you need to know all the time the interval. Like for this case, it's from 0 to 1, right? That's what we have, 0 to 1. So we have done those examples, but that was revolved about the x-axis. Now we are going to practice about the y-axis. Okay? So example, let R be the region in the first quadrant bounded by the graph of x is equal to y cubed and x is equal to 4y between x is equal to 0 and x is equal to 1. Which is greater? The volume of the solid generated when R is revolved about the x-axis or the y-axis. So we are going to do both, and then you will see the difference. Okay? So let's first do about the y-axis. So I'm going to graph, and we will see the interval of integration on both. Okay? So I'm going to make it small because I don't want to take too much space. You will see what the graph means. So, of course, the graph of um, x is equal to y cube be something like this, but the graph of x is equal to 4y is just like a line. Let me curve this one a little bit so you will see. Problem is graphing is kind of complicated for me a little bit. So this is a line. The line will be like this. Don't mind my graph. So this is like py is equal to 4y, okay? And then this is, the red one is like qy is equal to y cube, okay? Don't mind my graph. So, the interval of integration would be because this intersection is 8, 2. We can solve it by solving y cube is equal to 4y, okay? Like by solving y cube is equal to 4y, you solve y cube. minus 4y is equal to 0. So y will be 2. So this is 0 from 0 to 2. So when we said, let me erase this one because I want you to, when we said revolve about the y-axis, so the same graph that you have here would be revolving across the y-axis, okay? So you see what will happen is this one. And don't mind my graph. You see, right? So the volume that we will have generated will be something like this. And you know, this would be like my R. My radius will be something like this. Okay? So this is how the graph is, but again, try to understand your best, but the problem is practice. So again, as I said, solving y cube is equal to 4y, we will get this solution because you can factor y. If you factor y, it will left what? Y squared minus 4. So of course, by solving this one, we'll have two solutions, right? Three solution, I mean. We'll have y can be 0 or y can be 2 or -2, but we see we are taking 2, right? The positive one. So that's why the point would be 0, 0, 2, 2. I mean 8, 2. When x is y is 2, x would be 8. Okay? So now, when the region R is revolved about the y-axis, it generates a funnel with a curved inner surface. And then we can use the washer shape cross-section perpendicular to the y-axis extended from y is equal to 0 to y is equal to 2. So from 0 to 2. And the outer radius of the cross at the point y is determined by x is equal to py. So you see, this is the outer, right? The line, that's out. The green line, that's out. So that's the outer one. And the inner radius, so basically by looking at the graph, you can see the outer radius is what? The green one, which is py. So the outer radius is py is equal to 4y. And the inner radius is qy is equal to, I mean, y cube. So the washer method said v would be equal to 0 to 2 because that's the limit of integration, pi times py square minus qy square dy. That's the washer. Sorry, I'm writing something down now. Washer method, right? And I believe you know how to integrate this one. So my v would be equal to from 0 to 2. I can take pi out, right? Because pi is a constant. Py is what? 4y. 4y squared is what? 16y squared, right? Minus qy. Qy is what? Y cube. Y cube square would be y to the power of 6 dy. And then you just need to integrate this one. We will get pi 16 divided by 3y cube minus 1 divided by 7y to the power of 7, then 0 to 2. By solving this one, we will see v will be equal to 512 pi divided by 21. So now look, when r is, this is when it's revolved, this is when it's revolved about the y-axis, right? When it's revolved about the y-axis, that's what we just did. So now, when it's revolved about the x-axis, when r is revolved about the x-axis, first thing, foremost, we have the first curve when x is equal to y cube. This means what? Y will be equal to x to the power of 1/3. So which would be my f of x. And we have x is equal to 4y. This also will be what? Y will be equal to x divided by 4, which would be equal to my g of x. Right? So let me go to the next page and continue this one. So you can see, if I sketch this one again, the rule will not change, okay? You have to sketch to know your inner and outer radius all the time. Let me move this to yeah. Sorry. So if you look, if I sketch the graph, x is equal to 1/3, this graph will be something like this. But the graph of y is equal to x divided by 4 is a line. So this is y is equal to x divided by 4. And the red one is y is equal to x to the power of 1/3. So do you see? Again, this is my so which one will be the inner and which one will be the outer? radius. So you can see the inner radius is the green one, that's in and out, because it will be revolve about the y-axis. If it revolve about the y-axis, this is what I will have. You will have the same line in, and the red one will still be out. And then we'll come across this one, you see? And you will see this is the volume I will be looking for. And um, you see, so my inner is x divided by 4 and outer is x to the power of 1/3. And of course, again, we have to find the integration, but in this case we know this point is what, a2. So we'll be integrating from what, 0 to 8. Do you understand? So this is the limit of integration, 0 to 8. And you just need to set your volume formula now. So the V would be the integral from 0 to 8 pi. We know the let me use bracket. So if I use bracket pi f of x, which is the outer is x to the, you know what, let me put since I put f of x, let me put like f of x square minus g of x square dx. So now pi can go out. My f of x is x to the power of 1/3. If I square it, will give me x to the power of 2/3 minus g of x, which will be x squared divided by 16. So I believe you all know how to integrate this one. You should not spend too much time once you formulate. So this one will be pi x to the power of 2/3 will give me what? 3 divided by 5 x to the power of 5 over 3/3 minus x cubed. 3 times 16 is 48 from 0 to 8. And then you substitute 8, because if you minus, you substitute 0, but that will give me 0. If you substitute 8, you will see V will be 128 pi divided by 15. So the first one we get 512 divided by 21, and this is 128 divided by 15. So which one do you think is greater than? We see in this case we will conclude what? The region about the y-axis produce solid volume greater the volume. And that's it. Because we all know 512 pi divided by 21 is greater than 128 pi divided by 15. Okay, so let's do the last example. On this one, I really want you to practice. I'm going to do both, but you need to know in this case, this is when it's not revolve about an axis, right? Let f of x be equal to square root of x plus 1 and g of x be equal to x squared plus 1. Find the volume of the solid generated when the region R1 bounded by the graph of f and the line y is equal to 2 on the interval 0, 1 is revolve about the line y is equal to 2. And B, find the volume of the solid generated when the region R2 bounded by the graph of f and g on the interval 0, 1 is revolved about the line y is equal to -1. And finally, find the volume of the solid generated when the region R2 bounded by the graph of f and g on the interval 0, 1 is revolved about the line x is equal to 2. Let's finish this. So again, I'm going to make only one graph. I want you to understand that, and that's the same way when they said on A, when they said find the volume of the solid generated when the region R1 bounded by the graph of f and the line y is equal to 2 on the interval 0, 1 is revolved about the line y is equal to 2. So you need to know basically it's the same thing as axis, but it would just be revolved. Look. So in this case, if this is 1 and this is 2, so this will be it's just like my x-axis will be moved 2 up, okay? So now we are talking about f of x is what? Square root of x plus 1. So you know, if you sketch the graph of square root of x plus 1, the graph start from, it will be moved up 1 unit, and the shape would just be just like this, right? Should I make it big so you can understand? So you need to know is a square root graph, okay? So I'm just going to make it a little bit but okay, so it's just like this. Let me just use this. So this will be my R1. So if it's revolving about this one, so it will just be like this, okay? So now to find that so R1 and the x-axis of revolution. So if we apply the disk method, we see that a disk located at the point X has a radius of what? Who can tell me? This is moved 2 up, so it will be the radius R will be 2 minus f of x, which is 2 minus square root of x plus 1. So our R in this case will be what? 1 minus square root of x. Therefore, the volume of the solid generated by when R1 is revolved about y is equal to 2, V will be 0 to 1 pi times 1 minus square root of x squared dx. So again, this is applying the disk method, okay? We are applying the disk method because of what? G of x is equal to 0, okay? Because G of x is equal to 0 in this case. Just think like that. So we need to solve this one now. Okay, by expanding this one, our V would be equal to, take pi out, the integral 0 to 1 minus 2 square root of x plus x dx. And if you substitute 0, if you integrate this one, of course, you will get pi x x always take your time, okay? That is, this one will be negative 4 divided by 3x to the power of 3 divided by 2 plus 1/2 x squared from 0 to 1. So if I substitute my 1, you will see the volume will be pi divided by 6, because this will be 1 minus 4 over 3. 3 minus 4 is negative 1 over 3. And for this one, 3, yeah, pi over 6. Okay, so now let's move to B. On B, they said find the volume of the solid generated when the region R2 bounded by the graph of F and G on the interval 0, 1 is revolved about the line y is equal to 1. So for B, you know, when the graph of F is revolved about the y is equal to -1, it sweep out a solid of revolution whose radius, okay, so revolve about y is equal to -1. So you see, when it was revolved about y is equal to 2, we did what? 2 minus f of x. So in this case, it will be f of x plus 1, or 1 plus f of x, right? Because it will revolve. So it sweep out a solid of revolution whose radius at a point x is f of x plus 1, which will be what? F of x is square root of x plus 1. So square root of x plus 1 plus 1, then plus 1 will be what? Square root of x plus 2. And the same thing similarly when the graph of g is revolve about the y is equal to -1. We have g of x plus 1, which is g of x is what? X squared plus 1, which will be x squared plus 1 plus 1, and that will give me x squared plus 2. So using the washer method, because in this case g of x is not 0, so now using the washer method, the volume of the solid generated by R2. If you want, I can graph, but I just don't want to spend too much time graphing. We have done this. Will be V from 0 to 1 pi. Okay, yes, I have to graph so we can see which one is the inner radius and the outer radius. That's right. So y is equal to -1 would be somewhere here. And if you graph x squared plus 1, so let's say this is 1. The graph of x squared plus 1 is like a parabola, which would be something like this. And if you sketch square root of x plus 1, that would be something like this. So you can see which one would be, this one would be my R2. Okay, so you can see which one would be the inner and which one would be the outer. The outer would be what? Square root of x plus 2 in this case. So the outer radius would be square root of x plus 2. And the inner radius would be because it's about this x, y is equal to -1. So now since we know the inner and the outer radius, so we can assume our volume would be from 0 to 1 pi. Outer is square root of x plus 2 square minus the inner, which is x square plus 2 square dx. So then our v will be, we can take pi out, 0 to 1. If you distribute this one, of course I will get this one will give me x to the power of 4, but this negative will make it negative x to the power of 4. 4x squared. This will make it negative 4x squared. And we'll have minus 4, right? For 2 squared 4. But if I square this one again, this one will give me square root of x squared will give me x. That's 4 square root of x. And 4 and negative 4 will cancel out. So you will integrate this one. And if you integrate, which we have done, so you will see the volume will be 49 pi divided by 30. So I will let you do that, okay? I have paused the video and do it. So pause the video and also make sure once you integrate this one, you get exactly the same value as I did. Okay? And then C, which is the last one, find the volume of the solid generated when the region R2 bounded by the graph of f and g on the interval 0, 1 is revolved about the line x is equal to 2. So that's when we have to find the inverse. We have done this one also, right? The only difference is revolve about the line x is equal to 2. So on C, first we know the graph of f is described as a function of x. So we have to find the inverse, rewrite them as a function of y, f of y, and g of y, right? So for C, my first step would be, we know f of x is equal to y, which is what? Square root of x plus 1. That's what is given at the top, right? Yes. So we have to find the inverse. The inverse means what? We will minus 1 both sides. So we have, let me do that quick so you know what exactly we are doing all the time. You minus 1 both sides, you will have y minus 1 is equal to square root of x. To get x by itself, you square. So x will be y minus 1 square. Do you understand? So this is just to show you what your f of y. And same thing, g of x is x squared plus 1. We have to find the solution when y is greater than 1, right? So we have y is equal to x squared plus 1. We minus 1 both sides, we will have y minus 1 is equal to x squared. X will be equal to square root of y minus 1. Of course, for y greater than or equal to 1. So if y was less than 0, then we will have a minus here, okay? So now, since we have that, when the graph of f is revolved now, so we have both in terms of x, right? So when the graph okay, hold on. So the region R2 now is revolved about the line x is equal to 2 when the region R2 is revolved about the line x is equal to 2, we have to use what method? The washer method, because g of y is not 0, f of y is not 0, right? So we use the washer method. So we use the washer method. So now by using the washer method, first note that the graph of f is described by y is equal, so now when the graph of f is revolved about the line x is equal to 2, then the radius of the typical point at y will be what? 2 minus y minus 1 square, which would be my f of y. So let me call this one my f of y. This one is g of y. G of y, okay? So we don't get confused. And to find g of y, that also would be what? 2 minus square root of y minus 1, which would be my g of y. So now, if we extend, now if we observe that the extent of the region R2 in the direction of y is the interval what? In the direction of y is the interval 1 to 2, right? Sorry, I'm trying to break the page. Okay, so now if we observe that the extent of the region R2 in the direction of y is the interval 1 should be less than or equal to y, which should be less than or equal to 2. That's easy to find, okay? You can see this one was what? In the direction of 0 to 2, right? I mean, sorry, 0 to 1, right? But this point is what? This intersection is 1, 2. So this is 2. So that's why now to find this integral, to find the volume, to be from 1 to 2 pi 2 minus 2 minus y minus 1 square to the square minus 2 minus square root of y minus 1 square dy. Okay, I will let you integrate this one yourself. This is the practice. Let me pause, do it, and put the answer. So if you calculate correctly, you should get your V should be 31 pi divided by 30. And that's it for this section. So you need to know the washer and the disk method, the difference is when one of the function is 0, you just use the disk method. But if you have both function, use the washer method, okay? I will see you in the next section.